All right, questions? Yes, homework questions. 31 and 33. 31 looks fun. Capital F of x equals x to the 4/5 times x minus 4 squared. Okay, so if you recall that when we first were learning the different rules for derivatives, chain rule, product rule, quotient rule, a lot of times I talked about the raw derivative, but I said you want to get your answer to look like the back of the book and start playing with the algebra, because later on you're going to be having to set these things equal to 0 and do algebra. And so that time is now, and so that's probably going to be the questions we have. So the question here is saying find the critical numbers of this function. So we want here to know when capital F prime equals 0, and I also want to know when capital F prime doesn't exist, when the derivative doesn't exist, or when it's 0. So I'll start by just finding the derivative. So the derivative of capital F, I'm going to apply the product rule because I see that I have a product here. I cannot multiply this through here because I'd have to square it first. Now you could square it first and then multiply through and then do derivative that way also. I mean, doesn't matter as long as you do correct algebra. But I'm going to use product rule. So, well, I'll have to use chain rule when I get to this part of the product rule. So first thing is the derivative of the first function. What's the derivative of the first function? 4/5 x to the negative 1/5. That's the first thing. Then times the second function. I'm not touching this one. Plus, now the derivative of the second function, which is going to be a chain rule, because you have the squared on this binomial. So the 2 comes out first. X minus 4 to the first power, which I won't write the power, times the derivative of what's inside. What's the derivative of what's inside? 1. And then times the second function. I'm sorry, the first function. 4/5. All right. That's it. Now, I have to set that equal to 0. So let me do some algebra on this. You just follow along and tell me if you're okay with what I'm doing, or if you have any questions, you can stop me. So rewriting this, dropping the x to the negative 1/5 down to the denominator, it joins up with the 5 that's down there, so I put it like this. Now the reason I'm doing this is because I need to set this equal to 0. I have 2 terms, and if I want to set something equal to 0, I think what I'll do is I'll try and put them together as one fraction, so I'll get like a common denominator. But I'm gonna say that that's my derivative now, and I'm going to set this thing equal to 0. So here we go. Now, since I have 2 expressions, I'm going to put this second one over 1 just to clarify that I'm going to need a common denominator, right? This is a fraction. This one I can look at as a fraction, then equals 0. So let me join these 2 together. To do this, I must get a common denominator to be 5x to the 1/5. So I'm going to multiply the top and bottom of this fraction by 5x to the 1/5 down here 5x to the 1/5. Is that good? Yes? All right, so what happens? I have my 4x minus 4 squared over 5x to the 1/5 plus, now, I had a 2 out here. I have a 5 here, so that's going to become 10. So I've got 10. I have an x minus 4 to the first power. And then, what's x to the 4/5 times x to the 1/5? Just x to the 1, right? You add the exponents. 4/5 and 1/5 is 5/5, and 5/5 is 1, and x to the 1 is x. So I just have an x, right? And then over my common denominator. And since they have the same denominator, I can put them together. So 4x minus 4 squared plus 10 x minus 4 times x, all of it over 5x to the 1/5 equals 0. So that's what I'm trying to solve. Any questions up to that point? Now, something that happens here, that's going to happen all the time, is when you are trying to set a fraction equal to 0, right? I have a fraction equal to 0. The only time a fraction can be 0 is if the numerator is 0. So let me explain why. If I have a fraction, a over b, and I'm saying when is that 0, I should always be able to multiply both sides by b, right? Multiply both sides by b here, and what do you get? B on the left, b on the right. The b's cancel. I'm left with a equals what? 0. So what I'm saying is a fraction can only be 0 if the top is 0. So this fraction can only be 0 if I set the top equal to 0. So I can ignore the denominator is what I'm getting at. So I'm just going to look at 4 times x minus 4 squared plus 10 times x minus 4 times x equals 0. Now, you may be tempted at this point to just multiply this whole thing out. You know, square this and multiply through by 4 and then distribute a 10 through and then distribute an x through and get the whole thing together. It'll be a quadratic. You could do that. That's not wrong. But in future problems, it probably won't be a quadratic. So there's something more subtle that I want you to see here. We have a GCF right now. We have a greatest common factor. We have an x minus 4 that appears in both of these terms, right? So I'm going to factor an x minus 4 out of both. When I factor an x minus 4 out, I am left with, I'm going to put it in brackets instead of parentheses, just to stress that I've pulled this x minus 4 out of both of these. What is still left in this expression when I pull a single factor of x minus 4 out? A 4, and still 1x minus 4 is still there, right? What happens when I pull this x minus 4 out of this? Plus 10x. What's inside the brackets is a nice expression. I mean, I can distribute 4 through, combine things together. So I'll do that on the next page. I don't need the brackets. I can write parentheses. How many x's will I have? 14 x's, right? 14. And then we had, what, minus 16? So minus 16 equals 0. See, it's already factored now. I have two things that multiply to be 0, so set them each equal to 0. So x equals 4, and x equals 16 over 14, which reduces to be 8 over 7. 8/7 and 4. So far, those are my critical numbers. We good? Now, the second thing I need to look at is when does the derivative not exist? And for that, I need to go back and take a look at my derivative. And keeping in mind that my derivative was here, right? I simplified, I got a common denominator and did all this, and I had this expression. I could be looking here. I could look at any of these. Or I could be looking at this top one up here. Doesn't matter, because everything from this step down to this step, it was just algebra, right? So is there anything that when you look at this, you're concerned about happening that's going to cause this to freak out and not know what to do, to become undefined? Is there a value of x that's going to cause trouble here? 0, if x is 0. Because if x is 0, 0 to the 1/5 is 0, 5 times 0 is 0, division by 0 is undefined. So if x is 0, you've got trouble, right? You can see that right here. You can also see it right here, can't you? Right in the denominator. So on this second part, this is going to happen if x is 0. We get division by 0. And remember, the definition of a critical number is a number that makes the derivative equal 0, which is these two, or a number that makes the derivative not exist, which is x is 0. So we have 3 critical numbers, and we're done. Is that clear? Okay, 33. Oh, the trig one. I said that was going to be an issue, right? So 2 cosine theta, f of theta, sorry, they call it f of theta. F of theta equals 2 cosine theta Did I tell you all about the gazebo I built in my backyard? Yeah, I finished it like last weekend. But I got a fan, a ceiling fan to put in it. And I was all excited because it was like the biggest fan that they had at Home Depot. It was like, it was supposed to move 8,000 cubic feet of air or something like per minute. So I was like, the whole idea was that, I don't know if you've ever been outside in the summer in Texas in the evening, there's a lot of mosquitoes, right? So mosquitoes seem to always be a problem where I live. And so the one thing that keeps mosquitoes away is a fan, because they're not good at flying. So if you get a good fan on you, you don't get bit up, right? You can spray yourself with bug spray too, right? That works pretty good. But then if you're swimming, it all comes off, so what's the point? So anyways, I'm like all about this fan. I put it in, I install it, I run the electrical to it, I'm all excited, I turn it on, and it's pathetic. It's pathetic. So I'm excited because today my industrial fan is going to show up, and it's rated at 47,000 cubic feet per minute as opposed to 8,000. So I'm like ready to turn this up, like get it installed and turn it on. Hope that the gazebo doesn't fly away, but it might, man. It's just gonna be like suspended. No, it's mounted pretty good. It's not going anywhere. What's that? Yeah. Yeah. All right. Sorry. That's what I'm thinking about while I'm up here, just so y'all know. Well, I'm just I'm excited. All right. What do we do here? What are we trying to find? We want where the derivative little f prime is 0, and we want to know where little f is undefined or doesn't exist. It's kind of weird because we're saying where the derivative doesn't exist. We usually use does not exist when we talked about limits. But in the problem I did before, division by 0 was undefined. So those two words can be kind of used interchanged here, because remember, the derivative is a limit. If you go back to the definition of a derivative, it's a limit. So it's okay to use does not exist or undefined there. I'm only saying that because certain books will say undefined here instead of does not exist. All right, so derivative, we need that. Variables theta, so f prime theta. I don't write f prime x, that's incorrect. Derivative of two different terms, right? I do them one by one. Derivative of 2 cosine theta is negative 2 sine theta. Plus, now the derivative of sine squared theta, I have to use chain rule. Because the squared is happening as the last composition, right? So the 2 comes out first. 2 sine to the first power. Then chain rule, derivative of what was in there. Derivative of sine is cosine. Here's my derivative. Let's set it to 0. Did anybody here ever take this class called pre-cal? Yeah, yes, y'all did? Okay, great. This was one of the main goals of pre-cal. Hopefully your instructor was pretty big on that. One of the main things to come out of pre-cal, a good knowledge of the unit circle. And number 2, for me at least in my classes, solving trig equations, which requires some identities too. But this is a trigonometric equation. We need to figure out what thetas make that true. So we look at it, and we treat it kind of like we do a polynomial. We find a GCF. See the signs in both? Actually, a 2 sign. I can pull out a negative 2 sign or a positive 2 sign. What would you like? You want positive? Okay, positive 2 sign. Theta's coming out. What's still here? Negative 1 plus cosine theta. Okay, so I pulled a positive 2 sine theta out of both of these, which left me with a negative 1. Do not forget that negative 1, right? It has to be there. And then the cosine theta. Hey, 2 things that multiply to be 0, I set each one of those equal to 0. So I set 2 sine theta to 0. I set 1 minus, or negative 1 plus cosine theta equal to 0. And let's look at these one by one. 2 sine theta is 0. I don't like the 2 out there, so I'm going to divide both sides by 2. 0 divided by 2 is still 0. So sine theta is 0. Let's go do the other one right now, too. How about we move the 1 over to the other side? Cosine theta is 1. Okay. Not what I would recommend. Okay, here's why. If you do the inverse function, you're going to get one answer. Because the inverse function cuts your domain, and so you only would get one answer. What we want are all the answers. So, yeah, let's see how you learn this. It'll depend. Everyone, it's going to be different for every person. I know if you took me, I showed you one way and one way only. So this is the way we do this. If you haven't seen it this way, that's okay. Just try and follow along and ask a question. I go to the unit circle because I know the sign being 0 is one of the unique values on the unit circle. Cosine being 1 is also one of the common values. So if we go back to our unit circle, and we remember that if you're given on the unit circle a point x, y, that x is always cosine of the angle and y is always sine of the angle. So if I'm saying when is sine of an angle equal to 0, I'm saying when is the y-coordinate on the unit circle 0. So where does that happen? At what places on the unit circle are my y-coordinate 0? 0, the angle 0, and the angle pi, right? Those are the two angles that correspond to basically me saying, where is the y-coordinate equal to 0, right? Questions? So right now it appears that there are two possible answers, right? The angle 0 and the angle pi. But in pre-cal, you were hopefully taught how to get the general solution. And the general solution accounts not only for 0 and pi, but coming back around and getting 2 pi, and coming back around and getting 3 pi, or 4 pi, or 5 pi. Or you could have gone backwards and gone negative pi, negative 2 pi, negative 3 pi. So how do we say all those answers? Well, I'll tell you how I told my students to say it. The angle has to be equal to, I'm going to start out at 0, okay? That's pointed to the right. Plus, if I start at 0, where's my stick? If I start at 0, to get to the other angle, I have to add how much? Pi. And to get back to 0, how much do I add? Another pi. And then to go around again, pi again. So basically, as long as I move by increments of pi, I can get all the possible answers. So how do I say that? 0 plus, we're not raising it, we're just multiples of it. Pi n or pi k, depending on, again, your class, your teacher, your book. Pi k, pi n. N or k, do y'all care? K, n, k, n. What did we do in pre-cal? I don't even remember. Was it k? Let's do k. Where k is an integer. The book's probably going to use n because I used k. K is an integer. What is an integer? -1, -2, -3, -4, or 0, 1, 2, 3, 4. So integers are the nice counting numbers, including 0, both positive and negative. The mathematical way of saying k is an integer is to say k is an element of double struct capital Z. Double struct capital Z represents the integers. Double struct R is what? Real numbers. Double struct Z are the integers. So these mean the same thing. K is an integer. Oh, K is an element of the integers. So we need to just be clear that that K is what moves you around and gets you all infinite answers. Now, there's no sense in me having the 0 there, right? 0 plus pi k is still just pi k. So I could have just said theta is pi k. So how many answers is that? Infinitely many, right? I have infinitely many critical numbers. Infinitely many. That's only sine is 0. Where's cosine 1? So cosine, now I'm looking at which coordinate? Cosine is the x-coordinate. Where's the x-coordinate 1? Just at this angle right here, right? That's the only place where the x-coordinate is 1. What is that angle right here? We said 0, right? But it could also have been come all the way around, 2 pi, or go all the way around again, which would be 4 pi, or go all the way around 6 pi. Or I could have started at 0 and gone backwards, negative 2 pi, negative 4 pi, negative 6 pi. So how would I say that? Well, theta must be 0, that's where I'm starting, plus not pi, but 2 pi k. 2 pi k gives us full revolutions instead of half revolutions. You know, follow? So theta must be 2 pi k. But when you look at both of these answers, you don't need to write them both. Why? The first one already includes these, right? So it would be redundant to write this. It's like, okay, this takes care of 0 and pi and 2 pi and 3 pi. This is just 2 pi, 4 pi, 6 pi. It's already taken care of over there. So we could scrap this one. But we would need to look at it because it could have turned out to be something completely different. So no, because we've got them here. All right, that is where the derivative was 0. I also need to look at where the derivative was undefined. So where does the derivative not exist? So let's bring our derivative back up here. What was it again? 2, was it 2? Negative 2. Negative 2 sine theta plus 2 sine theta cosine theta. Is there anything that you could plug in here that would create a problem? How about the sine function? Is it defined everywhere? Both directions? Sine's perfectly continuous. Domain is everything. So is cosine. It's defined everywhere. So there's nothing that's going to cause division by 0. Right? There's no square roots. Nothing's ever going to mess that thing up, which means that we don't have anything from here. So our only critical numbers are pi k. Or pi n. What does the books have? Pi n. Be comfortable with pi k or pi n. Good. Anything else? What did I have you go through? To 33? 43. Anyone have any issues with 37 through 43? Did everyone get through 37, 43? Yeah? Okay. All right. So let's do a problem. There are no questions for 23 through 43. Odds. You didn't get two. So are you saying you want me to go through 43? Do y'all want me to go through 43 or not? Yes? Okay, so the instructions for 43 are different than for the ones we just did. What you have is a function on a closed interval, right? It says, find the absolute maximum minimum of this function on a closed interval, on this closed interval. So there are some things we have to look at first before you can get started. To find the absolute maximum minimum value of a function on a closed interval, you have to have certain conditions be met. What are those conditions? Continuous, thank you. If f is continuous on a closed interval, then it attains both its maximum and minimum values there. Then we can apply the closed interval method. But we have to have a continuous function. And because this function is not continuous on everywhere, we have to pay attention to that because it's a square root, and there is a possibility that we could have a negative under that root. So let's first check, is this continuous or not? Well, all radical equations are continuous on their domains. Meaning, wherever this function is defined, we can draw it without picking up our pencil. But there are going to be some places where it may not be defined at all. So let's talk domain. If we're looking at this, I know that this right here, 4 minus t squared, cannot be negative, right? Can it be 0? Yes, it can be 0. This has to be greater than or equal to 2. I mean, what? Just scratch what I just said. 4 minus t squared must be greater than or equal to 0. Right? That's what we're saying. Now, I want to go through this because I need to make sure that you know how to solve this correctly, because this is not a quadratic equation. It's a quadratic inequality, and the way you solve it is different than just a normal linear inequality. Does anyone know how to do this the right way? Anyone know it? Anyone that feels comfortable attacking that want to help me go about it? Or have I scared you away from it now? Okay, so you want to isolate the variable? Like move the t squared over? Is that what you're saying? Okay, let me go with that. Is that what you're saying? Like this? Is that all right with everyone? I added t squared to both sides. Is that okay with you? Anyone have any issues with that? Now what? You're going to do square root on both sides? Is everyone okay with that? Plus or minus whenever you do square root? Is everyone still okay? Okay, so this is two different statements. 2 is greater than or equal to t, and then the other statement is negative 2 is greater than or equal to t. Is that correct interpretation of this right here? So if I were to draw a number line, and I put negative 2 here, and I put 2 here, when you say that 2 must be greater than or equal to t, that means that t has to be to the left of 2, right? Anything to the left of 2, including 2? Yeah? Do you all agree with this? Everything this way forever is what that's saying? Okay? What is this saying? T must be smaller than negative 2. Here's negative 2, so t must be which way? To the left, so everything from here, including it, over. So what's something's not right? Yeah, but let's not consider that yet. I am going to look at this in a second, okay? But I want to know, first of all, can you tell me what the domain of this is? Like, because if this interval is not in our domain, we've got major problems. Major, major problems. But I want to make sure everyone is getting the right domain. How would you say this domain? Does it have to satisfy both of these at the same time, or what's the deal here? Is it just this stuff out here because that's where they overlap? Or is it just this? Or is this completely wrong? Yeah, see, look, let's just try a number over here. How about negative 3? It looks like from this that negative 3 should work, right? Because it satisfies both of these. Negative 3. Plug negative 3 in right here. Negative 3 squared is 9. 4 minus 9 is negative 5. And the square root of negative 5 is that's imaginary, and that's a big problem. So see where I wrote in red? That's where we made the wrong move. We can't do it. In fact, we don't do these at all like this. All right? This is called a quadratic inequality, and the method for doing this is not this, but it's worth showing because you don't want to do that ever on a test. All right? So the correct way of doing a quadratic inequality is as follows. You first, quadratic inequality. That's what that's called, a quadratic inequality. You first turn it into an equation. So convert it into an equals. Then go ahead and solve this, like we just did, and we'll get 2 answers. Is that okay? You could do that, move things over, square root both sides. But I've switched it to an equation. Do you all see that? I'm not working with the inequality right now. What this tells me is that if I use negative 2 or 2, I get 0, don't I? Yes? Which is okay to have because it says greater than or equal to 0. To determine whether or not the stuff to the left of negative 2 works or not, or the stuff between here works, or the stuff out here to the right works, we can do it 2 ways. The first way is just to test things. Just pick something, like pick something over here. Does it work? Negative 3, did that work? No. So what I would do is I would say, oh, everything over here to the left of negative 2 is no-go, so I put an X there. Nothing over there works. Then pick something in here. What's something in there? 0. Does 0 work? Yes. So that means everything between negative 2 and 2 will work. You don't have to check the rest. And then you pick something out here like, what, 3. Does 3 work when we plug it in there? No. That means the only stuff that works is the stuff between -2 and 2. Okay? So everything between here and here. So the domain of this function is everything between -2 and 2. As long as we're inside that, we're good to go. What was it? I'm going to use x square root squared. I'm going to graph it just, for fun. When I graph this, the picture should only show up between -2 and 2. Nothing else should appear. Right? The graph has no meaning out here, has no meaning out here. So if we're going to be looking at max min values of this function on a closed interval, we have to make sure our interval is inside there. Now let me go back to the interval. Is that between -2 and 2? Yes, I'm in there. I'm good. Okay, the interval's okay. Now I said that this is one way to do it, right? That's not the way I prefer, but that way it'll work. This will work for any polynomial inequality. I think the better way to do it is just to think about using the same logic. You have -2 here and 2 here like this. And then just think of this as a parabola. This is a parabola, right? Which way does it open? Down. That means my parabola has to look like that because these are the x-intercepts. If I want to know when it's bigger than or equal to 0, I'm saying when is it above the x-axis? That means it has to be between here and here. That's, to me, easier than doing test points, but it only works for parabolas or quadratic inequalities. Either way, you do not want to do this thing, all right? We talked about the toilet paper on the shoe? No? Okay. That was my other class, sorry. I was telling my other class that we were doing something in a Cal 2 class, and the answer came out to be 5, what was it? I don't know, it was like 5 halves or something. And it was like, okay, what's the answer? And someone said 2.5, like that. So these are the same, right? But we don't use these. We don't use mixed numbers in calculus. We just don't use them. Very rarely will you see a problem that has a mixed number in it. And mostly because people lose sight of the fact that 2.5 really means 2 plus a half. So it's like bad notation. I don't know. Think about what if I wrote 3 1/4 x squared, right? Taking the derivative of this, like, you see, like bring the 2 down, just kind of weird, right? Yeah. So I told them, I said, writing this down is like kind of like walking around with toilet paper on your shoe. It's like people look at you and it's like, okay. You're right. I have major problems with those things. These are called what? Mixed numbers? And they're used now. Granted, they are useful when you're trying to add things like 7 3/4 plus 2.5. Then you add these up. It's 9, and then you add these up. But you still need a common denominator. I personally am against them, but they do teach them in elementary school. So, I mean, that might explain part of the reason why people don't like fractions is because there's like 2 versions of them, and I don't know. So, toilet paper on the shoe, right? This is like, I hate to say it, doing this is like a little worse than that. It's kind of like messing yourself up and, messing your pants up and walking around with it, Like this is just really bad math right here. It would be quite embarrassing to you to do this on a test, right? Quadratic inequality. If you took 1414, you do that in 1414. I know that because I taught it this semester. So, all right, but it's been a long time if you did. Have we even started the problem? We haven't, right? We need to make sure that we had the domain straight. Now we can do the problem. So the interval that we have appears within the domain. So yes, we have a continuous function on a closed interval. We're ready to go. So ready for derivative? F prime of t. I think I'll use product rule because I see a product right there. Derivative of the first one is 1 times the square root of 4 minus t squared plus chain rule. Derivative of the square root of something is 1 over 2 times the square root of that something. Am I done? Times negative 2t, right? Because the derivative of what's inside of that was, derivative 4 was 0, derivative of negative t squared is negative 2t. Am I done? Times t, because that's the first function. Okay, so there's my derivative. I clean up. I see some 2's going away here. I see a plus sign becoming a minus, and a t squared going on top of a square root of 4 minus t squared. What's wrong? Yes. Yeah, let's do that. Okay. I just want to show you. Is everyone okay with this derivative? Okay. If you take the original function and you're saying rewrite the square root as 4 minus t squared to the 1/2 and do the derivative this way, the derivative would be 1, so I don't need to write it. It'll be 4 minus t squared to the 1/2 plus what? 1/2 4 minus t squared to the negative 1/2 times negative 2t times t. And that's the same exact thing. But here's my fear, all right? And this is why when I was teaching you the derivative of the square root, I tried to force you to look at it as 1 over 2 root. 1 over 2 root, right? That's what I kept on saying. Yes, you could always do this. Here, the reason why I avoid this is because a lot of times when we get to this point, the people who do this don't know what to do with it algebraically now. Whereas when you're here, where is it? When you're here, you might look at that and go, common denominator. As opposed to looking at this and going, why am I in this class again? You know, like, you may not know algebraically what to do with that. Like, how do you, I mean, that's a question you have to reflect yourself. Do you know how to set this equal to 0? Do you know you're going to need to take that and drop it down to the bottom? Do you know you're going to need to make them square roots, turn into square roots? Like, are you comfortable with that? If you are, good. This is right. It's not wrong. It's, you know, there could be a hang up in the algebra now. So, may I proceed with this one? Okay. I know I'm keeping in mind that I'm going to set this to 0. So I'm going to continue to simplify this by going ahead and getting a common denominator here now. May as well do it now. I write that one over 1. My common denominator is root 4 minus t squared. So I need to introduce it on the top and bottom here, right? Oh, my package is there. My fan is on my front porch. Ready to go. Let's go. Have a good weekend. No, kidding. I'm just deciding if I should just squeeze the root in here or just write a new line. What do you want? Write a new line? Do you want me to do it or write it in there? Like, do it and show what it would be, or actually show it over itself? Never mind. I'll just do it. Here it comes. 4 minus t squared, root 4 minus t squared. That's what I'm introducing on the top and bottom of this one. And then the other one I'm not touching because it was already in the form I needed. So when I do this, here's what I introduced. There was my 1. And so when I multiply a root times a root, same radicand, the roots go away, it's just 4 minus t squared, right? So I have the 4 minus t squared over the square root of 4 minus t squared minus t squared. Is it t? It's t squared? That might be where you have the problem. No? So there's these two multiplied, and then now I have the same denominator. Put them together, new page. I have 4 minus t squared minus t squared again over the common denominator, which is finally a very good-looking derivative. There it is. That's my derivative. So, when is it 0? I could factor 2 out. Yes, I could. But it's not going to really make it like anything cancel, so it's okay, just leave it there. Set it to 0. Well, it's a fraction, right? So the only thing I need to concern myself with is what? The top. I should point something out. I said a fraction can only be 0 if the top's 0, right? When you go back and look at the example we did before, nope, the one before that. This was our derivative, right? Remember that? And we set it equal to 0, and I got a common denominator and put them together. And then I set the top equal to 0. You cannot do that at this point because you do not have a single fraction. You have a fraction plus another fraction. The only way you can say that a fraction equals 0, the top is 0, is if it's one fraction. So you could not just look at this and be like, oh, I just need to set that to 0. Do you understand that? Because this is not, has not been incorporated into the expression yet. Yes? All right. That's it. So this is a quadratic equation. So yes, you can do this the standard way of solving an equation. I think I'll take the 2t to the other side to make it a positive, or 2t squared to the other side to make it positive. I'll divide both sides by 2. I will take the square root on both sides. When I take the square root on both sides of an equation, I introduce two solutions, positive and negative. So square root of 2 and negative square root of 2. But I have to check to make sure that these both lie in the interval, right? What was my interval in the original problem? Not my domain, but the interval I'm looking in. Negative 1, 2. Okay. Positive root 2 is about 1.414 something, right? 1.414 lies in here. Negative root 2 is negative 1.414 something. So the negative root here doesn't live in this interval, so I'm chunking it. I don't need it, right? I'm looking outside the window of where I'm looking. So the only real value that I have here for critical number is root 2. Because negative root 2 not in here, all right? I should draw the arrow the other way. The negative one is not in there. Am I done? No. Now I need to get anywhere where the derivative was undefined. So you look at the derivative and you tell me what's going to mess this thing up. We have a square root of 4 minus t squared, don't we? Another weird square root where we have to look at every possibility. So this becomes another quadratic inequality. But we don't have to go through all that because we already did in the previous part. In the previous part, when we looked at domain, we said -2 to +2, right? Including -2 and +2. Can you have -2 and +2 here? Am I allowed to plug 2 into this? I'll get square root of 0, which is 0, but then it's division by that, right? So I have to, 2 is not a good thing to have, and -2 is not a good thing to have. So t equals 2 and t equals -2 are critical numbers. I don't ever look outside the original domain. Look, the original domain right here, that was a domain. We don't ever consider anything outside of that. The interval -1 to 2, we ask ourselves, do these lie inside that interval? Well, -2 doesn't, right? That's not in the interval that we're looking. But what about this one? Yes, it's an endpoint. It's an endpoint. So these are our two critical numbers, 2 and √2. All right, so going back to the closed interval method, to find the absolute maximum values of continuous function on closed interval, we find the critical numbers and evaluate f at those critical numbers. Evaluate the function. So I need to evaluate the original function at those points, then evaluate the original function at the endpoints, compare the answers. The biggest one I have is the max, the smallest is the min. Stay tuned next week. All right? So I need f of √2. I need f of 2. Okay, these come from my critical numbers, right? Those are my critical numbers. And then the endpoints are f of what? -1 and then f of 2. Do we notice that that we have repetition here? One of our critical numbers is one of our endpoints, so we don't have to do it twice. We really only need to evaluate the function at 3 places. So let's plug √2 into the original function. When you do it, you get t, which is √2, right, times, I forgot what it was, the original function. Okay, so then square root of 4 minus √2, but then squared. So √2 times square root of what? This is just 2 when you square it, right? 4 minus 2 is 2. So 2 times √2, which is, √2 times √2 is 2. Now you plug 2 in. 2, square root of 4 minus 2 squared. 4 minus 2 squared is 0. So this is just 0. And then lastly, -1 square root of 4 minus -1 squared. -1 squared is 1. 4 minus 1 is 3. So this becomes -√3. Which of these is the biggest one? 2. The smallest? -3. So when we say small, we mean the biggest negative, right? On a number line, which is furthest to the left. So here's the way I'm going to write it. I have a maximum, and it happens at √2, 2. I have a minimum, and it happens at -1, -√3. Agreed? And I said that's the way I prefer you write them, as ordered pairs. And that's my answer. Does that match up with the book? Okay. Do you see the... Okay. Good. Now, I could verify this by coming back. This was the graph of the whole thing, right? If I restrict this to just -1, 2, I'm looking at just this. That doesn't look right. That did not do what I wanted it to. -1, 2. There we go. So I was just looking here, and I said that I should have an answer of, one of them was what? It was √2, and then 2. So when I plot this point, I should get a dot at the lowest point on that graph, or highest. Sorry, it was the max. There you go. There it was. That verifies that what we did was correct. And then if I do another point, and that one was what, -1, and then -√3, it should draw a dot right there. So we found the highest and lowest points on that graph on that closed interval. A lot of work, right? There's a lot of work involved. I mean, we've done, what, 2 problems, and we're an hour in. With 3, yes. But we didn't, this is the first one we did the whole thing on. Okay. I'm debating mean value theorem or quiz. Mean value theorem or quiz here. Let's do a quiz. Let's all do a group quiz. This is going to be fun. Okay? And this will be it. This will be the end of the day after you finish this quiz. All right? Because it might take you that long. All right? So here's what I want you to do. No. I'm going to be here today. So get a piece of paper out, write your name on it, put today's date. Everyone will turn in their own, but I want you all to work together. The first one, find max and min of f of x equals x minus natural log x on the interval 1/2, 2. And then after you do that one, same instructions, find the max and min of f of x equals x minus 2 arctangent x on the interval 0, 4. What did I give you up through? 43. I think what you should do now for homework is the same page, 209. But now you should look at 38 through 46 evens. What you're doing right now is an in-class quiz is number 48 and number 50. So these 2 problems are right out of the book. This is number 48 and number 50 out of the book. So work together, see how you do. I'm going to go install my fan. I'll be back in 45 minutes now. I'm going to try and not answer questions. I mean, I will eventually, but I want you all to all hit a dead end. Your whole table is stuck. All right?